In this video, I will show you how to use our libraries and Intel libraries. First, we try to control an LED strip, so I add the LED strip library. In the file, you find some information on how to use it. But in our GitHub, you can also find a lot of examples. Here you can see the example for the LED strip library. I first automatically create the signals and set the parameters. I can hover above the name and see some information. For our FPGA boards, 12 MHz is correct. I set the number of LEDs to 10, and because I use the WS2812 LEDs, I can keep the default value and delete this line. I keep the update input enabled, so the address just iterates through the LEDs. Now I can update the color of the LED on every pixel clock edge. First, I can check the address of the current LED, and then set the color for the next LED. If you want to use Intel libraries, these are folders with the QSYS and QIP file. First, we add a phase lock loop to create a clock with different frequency. I add the library to my project and click on the QIP file to set the output frequency. We use the 12 MHz clock as input and create a 50 and 100 MHz clock as output. After I click on Finish, I create a new component, and then you can use the default clock called CLK as input. For the output, I can create the signals and use the clocks for a process. Note that in a thread, the wait function calculates the time to wait with a 12 MHz clock, so you have to use the wait calculator to calculate the cycles to wait between the operations. I let an LED blink every second with a 100 MHz clock. Finally, I show you how to add QSYS libraries like for the SDRAM. First, I add the SDRAM folder. The library is configured for the SDRAM on our supported development boards. But you can also click on the QSYS file to change the settings. I delete the sim parameter and reset input to use the default values. Now I create the signals. The signals to read and write and a clock signal with the speed of the SDRAM is created. By default, it is 150 MHz. I use this clock for a thread in that I first write the numbers from 0 to 99 in the RAM with the write function. The function has two inputs. I use the signal I as 16-bit data and address. I also have to connect the signals of the SDRAM component. After that, I add an ISSP to verify that the data is saved correctly. I changed the number of inputs to 16 because the RAM stores 16-bit values. In the VHDP support file, I also have to change the number of inputs. Now I create the signals and use the read function to read values from the RAM. The data at the position determined by the source signal is written to the probe signal. In the next video, you can learn more about functions. I have to remove the PLL because the SDRAM needs a PLL and the selected FPGA does not support the current setup with 4 different frequencies. Now connect the signals and click on Compile. Program the FPGA and open the ISSP window. Now enter one number and activate the output to see the number at the position in the RAM. You should also see the LED blink. And if you connect 10 WS2812 LEDs, you should also see the color you choose. But don't connect too much LEDs while powered with the USB port because of the needed current of the LEDs. In the next video, I will show you even more advanced VHDP programming.